Namaskar listeners, welcome back to another exciting episode of Pal Talk Machine Learning. I'm your host Dr. Chinmoy Pal, and today we are going to explore something that's simple but incredibly powerful: autoencoders.
And I'm Ria. Autoencoders are like data whisperers. They learn to compress and reconstruct data in a way that makes them highly useful for a range of machine learning applications, from noise removal to anomaly detection. What is an autoencoder?
To put it simply, an autoencoder is a type of artificial neural network used to learn efficient representations of data, typically for dimensionality reduction or feature learning.
It's called autoencoder because it learns to encode the input into a lower dimensional representation and then decode it back to the original. The idea is to capture the most essential features of the data.
Structure of an autoencoder. An autoencoder has three main parts. Encoder. This part compresses the input data into a latent space representation. Bottleneck, the lowest dimensional point which holds the compressed knowledge. Decoder, this reconstructs the input from the compressed data.
Think of it like zipping and unzipping a file. The encoder zips the data and the decoder tries to unzip it back to the original form. What do autoencoders learn?
Autoencoders are trained in an unsupervised manner. The goal is to minimize the reconstruction error, the difference between the input and the output.
If training is done correctly, the model learns to ignore noise and focus only on the meaningful features. This makes autoencoders perfect for denoising images, detecting anomalies, or even pre-training deep networks.
Applications of autoencoders. Let's talk about some real-world applications. Image denoising. Autoencoders can remove noise from images by learning the clean patterns. Anomaly detection. In banking or cybersecurity, autoencoders are used to detect unusual patterns that differ from the normal reconstruction. Recommendation systems. Compressed features from autoencoders are used for suggesting products or movies. Data compression. Similar to PCA, but in a more non-linear and powerful way. Medical imaging. Used to reduce dimensions in MRI or X-ray scans.
And let's not forget generative tasks. Variational autoencoders or VAEs can generate new realistic samples from the learned data distribution.
That's right. The basic autoencoder is just the beginning. There are many variants such as denoising autoencoders, learn to remove noise from inputs, sparse autoencoders, encourage the network to learn only a few active features. Variational autoencoders or VAEs add a probabilistic twist, allowing data generation. Convolutional autoencoders designed for images using convolutional layers.
Each type is used for different tasks depending on the complexity and the nature of the input data.
Limitations. Autoencoders are powerful, but they're not perfect. They don't always generalize well to data outside the training distribution. Also, unlike PCA, autoencoders can be more difficult to interpret.
And training deep autoencoders requires a lot of data, good regularization, and careful tuning, but the results are often worth the effort.
And summary? So to summarize, autoencoders are a brilliant way of teaching machines to compress, reconstruct, and understand the underlying structure of data without needing any labels.
They're useful for compression, denoising, anomaly detection, and even generating new data in a more creative and controlled way.
That brings us to the end of today's deep dive. I hope this episode helped you demystify the concept of autoencoders.
Don't forget to follow Pal Talk Machine Learning on your favorite podcast platform for more such episodes. Until next time, keep learning, keep decoding, and stay intelligent with your data.